Okay, you're probably wondering why we're running a line from the washer into the bathroom and outside and coming out the window through the heated sun through over here. We have hot water pumping through the hot water of the washing machine. We disconnected and plugged the garden hose. This is pumping at 100 degrees. Watch out, I might get burned. That's hot. Holy cow, that's burning hot. See, right now, water's 70 degrees in the pool. This should bring it up in 20 minutes we're gonna give so we don't run out of hot water. Give it 20 minutes, this should go up to like 80 degrees. Also, we had some sunlight before, but it's not as good. You can see it's no longer in the pool because of the trees. The trees are blocking it. But we had these two buckets because black absorbs the heat. It makes it hotter quicker. And the white reflects the heat, so it goes back in the air. That's why it's not as hot. You can see right now we're getting very low radiation from the sun. This is what it should be looking like, spinning fast in the sun, and now it's slowed down. You can see how hot the water's coming out at 120 degrees. I had to take it out because if I had it anymore, the mercury would overflow. We had to shut the water off because we ran out of hot water, and it only went up. It started at 69 and now it's only 71, so it only brought it up 1 degree in this one area. In this one area on the steps. It would have taken like probably a half hour just to bring up cool 1 degree, but we ran out within 10-15 minutes. Now we have to let the hot water cycle recharge again to bring hot water for the showers because we ran out. It was like room temperature, but it felt good at the last few minutes. It wasn't scalding hot anymore. You could see it's about 425, and then if this was in the middle of the summer, the sun angle would be much higher, but since we just hit the fall equinox, it's equal to the Capricorn and the Tropic of Cancer, so that means the sunlight is equal, so it's going to be in the middle instead of full peak of sunlight. And then that's why in the winter solstice, which we're learning in meteorology, that the sunlight's going to be even lower, so that means less heating because of the trees, but also the shadow length is going to be much longer, a good 10-15 feet. But in the summer it would probably be down to my feet right there, because the sun would be right on top of my head, so it's shining down. And in the winter, it would probably be about 50 to 100 feet. That's how long it could be. Also, we used this tarp. We had it in the pool before, but covering partially, but it keeps the heat in. It's like a greenhouse effect. The heat comes down, it warms up the pool in the daytime, and then the heat doesn't escape. It traps the heat in, so that's pretty good. But this is only like a 8 to 10 foot thing, so it only covers like a small section of this area. You need like a whole 30-foot cover to cover this, and we're not going to do that every night and every day. And you can see the reflection right there on that watering can. It's only about 2-3 feet, but that's because it's small. We have this thing right here. It's for like holding a lamp, and you can see how far the distance is. It's probably about 8 feet right there, so the taller it is, the more shadow you get. Okay, you could see that there's going to be a high albedo, cloudy day like today. It's going to actually get warmer in the evening from all the solar radiation that's been blocked by the clouds. It's going to come down and keep us warm. It's going to trap us like a blanket, like a greenhouse effect. Up in the upper elevations, if you go to the upper atmosphere, the clouds are reflecting the sunlight, and they're bouncing off because white reflects it, and you had no clouds, they would come all the way down to the ground. This is what it looks like on a normal day. You have a large range of temperatures. It starts off cool, and then it goes, when the sun comes out at the peak temperature of the day at 12 o'clock, that's when it spikes up, and then it shoots right back down. All the solar radiation is going back out to space. Here's another look of albedo, the reflection and absorption. You asphalt the ground, the pavement, it's dark, so it absorbs 90% and it only reflects 5 to 10% back. Dark roofs reflect 10 to 15%, so they absorb about 80% of the heat. Water has a high specific heat, so it takes longer to heat up the water, so it only heats it up 5% to 80%. Sometimes varies with sun angle, but usually a low percent of heat is absorbed in the water. Sandy beaches, they reflect off a lot. They reflect 80%. They only absorb 20 to 40%. And snow, right here, they could bounce off 90% off. That's why it's blinding, because 90% of the light is bouncing off into your eyes. And clouds, only 20% of radiation is absorbed by the clouds, so that means 80% of the solar radiation is bouncing off, so that's why it's not too bright today. It's only 20% of our light. You can see we're out here, and you can see there's a high albedo today, which means the sun reflects 90% of the sunlight, which is That's why it's very blinding. You need sunglasses or you'll get blinded by the snow. This is good for the polar areas like Antarctica because the sun, it just bounces off all the solar radiation. All the snow melted on the cement and the pavement because it's black, so it absorbs the heat. It melts anything on the contact on the pavement. See right over here, we're going to talk about the Earth seasons with the sun. We didn't have the Earth on an axis of 23.5 degrees. We'd have the same weather all year long. Stay really hot in near the equator. The sun rotates around the Earth, and you could see this is the perihelion is when the Earth is closest to the sun at 4.5 million miles away, and then aphelion is when the sun is farthest away from the Earth is the farthest away from the sun at 14 million miles away. Also, unequal heating of the sun creates weather and waves, and without the sun we wouldn't have any weather. The Earth also spins at 15 degrees an hour because you could see the Earth 360 degrees for one full circle, and also you could see 360 divided by 24 hours in a day, so that would be 15 hours, 1 hour, 30 degrees, 45 degrees, and so on. Also, you could see this is the spring, and this would be right here when the sun's closest to the equator. This is the spring and the fall equinox. This is the Tropic of Cancer, so when the sun hits the Tropic of Cancer, it's our first day of summer in the northern hemisphere and winter in the southern hemisphere. And also when the sun hits the Tropic of Capricorn at 40 degrees south, it's our first day of winter in the northern hemisphere and the first day of summer in the southern hemisphere. Okay, we're going to tell you about the Earth's atmospheric levels. You can see right here is the troposphere. This is where where we live, and this is where the weather takes place. It goes up to 6 miles high. You can see there's Mount Everest. It starts off at about 80 to 90 degrees at the surface, but as you go up in elevation to the top of Mount Everest, it goes down to negative 80 degrees. And then here you go into the next layer, the stratosphere, and this is where the ozone layer is, where it protects us from the harmful UV rays from the sun. Volcanoes and snow eats away at the ozone, so that's not good, because one time there was a part where they had an ozone hole, where that means the sun came directly down. There was no ozone, so that's bad because ozone protects us from harmful UV rays. And then as you go up higher, the temperature goes up, and when you go to the stratosphere, the temperature goes from negative 80 degrees to 32 degrees. And then we have the mesosphere. This is where the meteors and the planes, sometimes they fly up to there. And they launch the weather balloons right over here in the mesosphere. And it goes from 20 degrees to negative 120 miles. And it's from 30 miles high to 50 miles high. That's pretty high. And then we have, the temperature goes down to negative 120 to up to 120 degrees. So this is, you don't feel any, there's no atmosphere, so you can't feel the intense heat. You need like a special insulated jacket, because right here you could get burned at 120 degrees and it'll feel like 60, 70 degrees. You won't feel it. And this is where the northern lights, the aurora borealis, and the satellites take place over here in the thermosphere, and it's from 50 to 90 miles high.